Hi, I'm Mr. V, and today's lesson is 5.14, where it's practice with pyramid and prism volume, pyramids and cones. And before we begin this lesson, I started off the class, and I'd like to do this now with a quick review of some of the topics that we've talked about in this class that you're going to be tested on very soon. And so to do that, first thing we talked about was the volumes of a rotation. So if I took a two-dimensional figure, a rectangle, and I rotated around this axis, I ended up with a cylinder. If I took a triangle and rotated it around the axis, I would get a cone. And I could rotate it around a different axis and get a different volume, even though it's the same triangle. But here's my cone. And if I took a semicircle here, half of a circle, and I rotated it around the axis, I would get a sphere. A second thing that we looked at in class was a cross-sectional area. And I'll do this one with a cone, just because we're talking about cones today. So here I have a cone, and if I move the height of this plane up and I cut it at a cross-section, you see I'm cutting it like this, I'm slicing it. What kind of shape does it make? When we view it from the side, you can see it's going to be a circle. So that's if I have a horizontal cross-sectional area. Now, what if instead I had a vertical one? I had it straight up and down. And what kind of shape would that make when I look at it head on? Well, if I go from the apex, that would make it a triangle. If I move it further closer, it's not still going to be a triangle all the way up. It's going to be a curved section. The only place it's going to be an apex triangle is if it's from the apex, from the top point. I could still take this plane and I could tilt it. I could tilt it sideways, and I'll do that now. And what kind of shape is this going to make when we tilt it sideways? If I look at it from head on, from the plane, you see that this is going to be an ellipse. It gets smaller and smaller, like that. An ellipse. It's like an elongated circle sort of thing. So what kind of shapes are formed by doing cross sections? That's the second thing that we looked at in class. The third thing that we looked at was scale factor. And I'll put this K in a blue here because scale factor is so important. I have a point of dilation or a center of dilation. And this is when the K value is equal to 0. It has no dimensions, no length, no width, no height. This is where we were going to go from in order to get to our figure. And if we go a scale factor of 1, it will take us all the way to the figure. If I go somewhere between 0 and 1, like say 1/2, I'm going to start at the point of dilation. I'm going to go down, but I'm only going to go halfway. So I'm going to draw my line here through each of the vertices of the original drawing. I will only go halfway, or whatever the K value is. If my K value is more than 1, if it's doubled, say for instance, I would go down to the K and then further. But I'm always going to start at this point of dilation. Along with these are three formulas that we deal with. When we scale up a length, we're going to multiply it by our scale factor to get to the new length. When we do an area, we have a length component and a width component. The length is scaled up by K and the width is scaled up by K. So that's why it's K squared times my original area. It gives me my new area. And the volume, again, it has a length, width, and height component. So it's going to be scaled up in 3 directions. So it's K cubed. These are formulas that were important for us to learn. And this last piece, well, we have this cylinder. This is called a prism and a cylinder. The cylinder has a circular base, but otherwise these are very similar. They both have the same top as they have the bottom. And the formula is the area of the base, the capital B, times the height. And that doesn't matter whether it's right or whether it's oblique, whether it's tilting over to the side, oblique. It's still going to be the area of the base times the height. The height would be the vertical height going from the top down. These two are different. This is a pyramid and a cone. Again, they have a base. This is a circular base, but the formulas are very similar. It's 1/3 the base times the height. And the way that we did this, we created 3 pyramids and we combined them to be a prism. The area of the volume of the prism is the area of the base times the height. And since it took 3 of these pyramids to make it, this is how we derived this formula. We came up with this formula. Today our focus is going to be on these problems right here and doing practice with pyramids and with cones. So in the Desmos, we started off by telling me just answering a question. This is from the Illustrative Mathematics, Unit 5, Solid Geometry, and working with pyramids. That's what our big idea is. By the end of the class, you should be able to say, I can calculate the volumes of pyramids and cones, and given the volume of a pyramid or cone, I can work the formula backwards to find the missing dimension, either the height or the radius or whatever is missing. For the warm-up question, I had this. I have 3 figures. I have a starting figure, and I have the others 2. And you have to tell me, is A the same volume as this one? Is B the same volume? Are they both the same volume, or is neither of them the same volume? And I got a variety of answers. Let me show you how I would go about calculating this. And this is what I would expect you to do if you were doing this calculation. So first of all, we start off with the formula. The formula for the volume of a pyramid is 1/3 the area of the base times the height. Now this base here is a rectangle. So it's 1/3 times the length times the width times the height. Now I'll substitute the values. So I have 1/3 times 4 times 5 times 6. 4 times 5 is 20. 6 divided by 3 is 2, so 2 times 20 is going to be 40. And you can put this in a calculator if you don't believe me saying it's 40. Now, are these two the same or different? This is a prism. Formula for a prism is the area of the base times the height. No 1/3 in it. It doesn't go up to a point. The base is the same as the top as the bottom. So we have length times width times height, or 4 times 5 times 2. 4 times 5 is 20, times 2 is 40. Oh, these are the same. Here we have a triangular base. And what is the formula for the area of a triangle? Well, I should show you on this. If I have a rectangle has a length and a width, and it's going to be length times width. If I do a triangle, I'm going to still have a length and a width, but I'm looking at half of this. So it's going to be 1/2 times the length times the width, or the base times the height, if you want to do it that way. So when we do this, area of the triangle is equal to 1/2 the base of the triangle times the height of the triangle. This is the height of the triangle. This is the base of the triangle. My formula for the volume of a pyramid is 1/3 times the area of the base times the height. The area of the base is the triangle. So this is 1/3 times 1/2 times the base of the triangle times the height of the triangle times the height of the prism, or the pyramid, not to be confused with the height of the triangle. Now I'll substitute the values. 1/3 times 1/2 times 4 times 6 times 10, and you plug this into your calculator and you get 40. Indeed, all of them have the same volume. And you'll notice this one has a base of 5 and 4. This one has a base of 5 and 4. They have the same base. This one has a height that's 3 times as much, but it's 1/3 the height times the base. And this is just the base times the height. So these have the same volume because 1/3 of 6 is 2. And this one is going to be 1/3 because it goes to an apex. Now, going on with the Desmos activities for today, let's see. We are dealing with prisms. The idea is to find the volume, round your answer to the nearest tenth. I want you to upload a picture of your work on this page, but the big idea is to try to do the practice. Now I'm going to close this out and make this smaller so you can see it. And in each of these, if you type in the correct answer, it will give you feedback. I'm giving you the units, and if I have a 2 by 2 by 6 by 1/3, so my volume is equal to 1/3 the base times the height, which is equal to 1/3 times 2 times 2 times 6. I should get 8 as my answer. When I type in 8 here and submit it, you can see it gives feedback. And so for each of these, we would give feedback. This is a cone. The volume of a cone is 1/3 the area of the base times the height. The base is a circle. What's the formula for the area of a circle? Pi r squared times the height. Well, 1/3 times pi, the radius is given here as 2 squared, times the height, which is 4.2. And I can plug this into my calculator. I have 1/3 times pi, I type in pi for pi lowercase, times 2 squared of caret 6 squared times 4.2. And I get 17.6. When you plug the 17.6 into your Desmos, sure enough, it comes up correct. If you said 17.59, it would not be correct. You're supposed to round it to the nearest tenth. This is a pyramid. Volume is equal to 1/3 the area of the base times the height. That's 1/3 times the area of a triangle. 1/2 the base of a triangle times the height of the triangle times the height of the pyramid. So we have, this is a right triangle. So this would be the height and this would be the base. So we have 1/3 times 1/2 times 3 times 4 times 7. And I get the answer 14 kilometers cubed. And when you type that in, again, it will give you feedback as to whether or not you did it right. This one looks scary, but it's really not. It's a pyramid. So it goes 1/3 the area of the base times the height. And we're given the area of the base is 32 and the height is 12. So we can plug these into our calculator. 1/3 times 32 times 12. And I get for this, what do I get? 1/3 times 32 times, 12. I get 128. A particular cone. Write the formula for the volume of a cone. The volume of a cone is 1/3 times the area of the base, which is pi r squared, times its height. So this would be the formula. How did I get that? I used my basic formula. 1/3 the base times the height. This is the starting point for all of my cones or pyramids. Now is where it gets interesting. If this is my formula, 1/3 pi r squared times h, and we're given that the volume is 16 pi is equal to 1/3 times pi times, I'm given a radius is 3 squared times h. I can take this value. When I can divide both sides by pi, first of all, because I want to get rid of the pi. So I have 16 is equal to, and there I have 3 times 3 is 9, divide times 1/3 is 9 over 3 times h. This is just 3. 16 is equal to 3 times h. To get the h by itself, the inverse of multiplying is to divide. And I'll do that to both sides. And I'll put this in for my answer because these cancel. And when I do, I get the correct answer. So what we're doing is we're taking a formula, and given the volume, we're going to find a missing piece of it. So we have 1/3 times pi r squared times h. And in this instance, we're going to try to solve for r. So we're given this is 16 pi again. We have 1/3. We have pi times r squared. And here we're given that 3 is the height. Well, 1/3 of 3 cancels. I can divide both sides by pi, and I get 16 is equal to r squared. The inverse of squaring is square rooting. So I get r is equal to 4. And now we move to the next part of this lesson. This pyramid of Giza is 455 feet tall. The base is a square with 756 feet on a side length. How many Olympic-sized swimming pool volumes can fit inside? Well, you'd first have to find the volume of this, wouldn't you? Its height is 455 and it's 756 on a side. So if I were to draw a picture of this, this is 756. Half of it, why do I want half of it? Because I'm looking for the rate. No, I want this number. 756, the volume of a pyramid. I draw a dotted line so you can see it. I'm going to draw this height in red. Height is 455. So the volume is equal to 1/3 times the area of the base, which is 756 times 756. Oh boy, times the height, which is 455. This is in feet, I think. I think it's in feet. And so we go, if we multiply this all out, we have 1/3 times 756 times 756 times 455. And that gives me 86, what is it? 86,682,682, 9. I want to make sure I get it right here. 960. I say 88, 86, 682, 960 cubic feet. And we want to know how many Olympic pools would fit inside. So I need to know how many Olympic pools there are in a swimming pool. There's 88,000. Okay, I can do this. So I divide this by 88,000, and that would tell me, I think the answer is like 197 or something like that. An icy pyramid. In this one, you're given that the volume, let me see if I can find this one here. You're given that the height of the pyramid has to equal to 15. And the volume is going to equal to 720. So we need to find a base that would fit this. So if I put in my formula, volume is equal to 1/3 times the area of the base times the height. Substitute the values. 720 is equal to 1/3 times the base times 15. 15 divided by 3 is 5. If I divide both sides of the equation by 5, I get the area of the base has to equal to 144. Now, any two number combinations that multiply to give me 144 would work for the base. I could do 12 times 12. I want to start off with 1. 1 times 144. 2 goes into this evenly, that would be 72. 3 goes into this evenly, 3 would be 48. 4 goes into this evenly, that would be 36. 5 doesn't go into it. 6 goes into this 24 times. 7 doesn't go into it. 8 does. 8 goes into it by 18. 9 goes into this. 9 times what is equal to this? 16. 10 doesn't go into it. 11 doesn't. 12 times 12. Any of these two numbers could be my base. And I'm just going to choose 12 by 12. And a height is 15. Now, this is where it gets interesting. And this is where I think you're going to enjoy it. If you open this page, this applet here on this page, you can see I've got this figure, and I can move this around, shift it around. Three-dimensional object. I'm going to make the base 12. To do that, I have to make the, let's see if I make this taller. I have to make the scale go more. So if I push shift, I can move this thing around to make it get up to 12. And then this one too, I can make it move up to 12. And now I'm going to put in a rectangle. And you can try this on your own. This is like really cool. So I'm going to go 12. I go all the way over to the 12 here and all the way to 12. You have to go back to the starting point to finish the rectangle. And then I'm going to do this, which is extrude to, not to a prism, but I want to extrude to a pyramid. So I click in the middle of it here, and I want it to be a height of 15. And when I do this, you can see that, oops, let me see here. It's going down. I don't want that. I want it to go up. So I'm going to reverse this, and I'll do a negative 15. Height from here, and then let's just put in negative 15. Let's just see if this works. Now, when I do my volume, you can see there it is. It's got a height of 15. If you were to measure this, you see the height over here is 15. And what is its volume, I wonder? Well, let's take this thing here, measurement, and we take a look at it. It's a 720. And that answers our question. Yes, a 12 by 12 by 15 would work. And just to see if you understand this, there's a cool down question. You can show me your work. The lesson synthesis. Make sure you read the summary. I'm not going to read it here. The idea is, can you write the formula, substitute values, and solve? This last piece is a very interesting problem, and I want to show you how to do it in case you're listening and you are lost or don't know what to do. Given the volume is 36, and I need to find the dimensions for a pyramid that would work. Volume of a pyramid is 1/3 times the area of the base times the height. I'm going to say length times width times the height. 36 is equal to 1/3 times the length times the width times the height. And if I want to get this by itself, I'll multiply both sides by 3. 108 is equal to the length times the width times the height. Can you think of three numbers that multiply to give me 108? And yes, you could use 1, 1, and 108. That would be really weird. So what other numbers would work? Let's look at the prime factors of 108. To find the prime factors, I'm going to say, well, this is even, so 2 goes into it evenly. I'm going to start with the lowest numbers, 2 times 54. This is even, so 2 goes into it evenly. 2 times 27. This is not even. 2 does not go into it. 3, these two numbers add up to 9, which is divisible by 3, so 3 goes into this. Oh yeah, it's 3 times 9. 3 times 9, and 9 is 3 times 3. So my prime factors are all of these numbers on this little hockey stick thing here. This is equal to 2 times 2 times 3 times 3 times 3. So I could have a pyramid that's 2 times 2 times 27, or 3 by 3 by 12, or 6 by 6 by 3. Any of these would work. And that's the big idea, is to be able to work things backwards. So good luck with pyramids and prisms, pyramids and cones. Thank you. Bye-bye.